What if I told you? Pause that everything we know about the universe, all our best theories, all our most trusted calculations, might be wrong. And the reason we got it wrong is because of where we live. Not the United States. Not Earth. Not even our solar system. I'm talking about something so massive, so unimaginably large, that it makes our entire galaxy look like a single grain of sand on a beach. Scientists call it the KBC Void. And our galaxy, the Milky Way, is sitting right in the middle of it, a hole in the universe. 2 billion light years across, nearly empty. And we've been living inside it the whole time, without ever knowing it. Today, we're going to break down what this void actually is, why it's shaking up modern physics, and what it might mean for one of the biggest mysteries in science. Why haven't we found alien life yet? Stay with me, because this one will change how you see the night sky forever. Let's start at the beginning. In 2013, 3 astronomers, Ryan Keenan, Amy Barger, and Lennox Cowie, published a study that quietly rattled the astronomy world. They had spent years mapping galaxies using something called redshift surveys. Here's the simple version. When a galaxy moves away from us, the light it emits stretches out. It shifts toward the red end of the spectrum. By measuring how much that light shifts, astronomers can calculate how far away a galaxy is and how fast it's moving. Keenan and his team used this method to map thousands of galaxies in our cosmic neighborhood. And what they found was shocking. The region of space around us, stretching out roughly 1 billion light-years in every direction, had far fewer galaxies than it should. We're not talking about a slight dip. We're talking about a region that is roughly 20% emptier than the average part of the universe. To give you a sense of scale, most cosmic voids, those empty bubbles in the cosmic web, are maybe a few 100 million light-years across. The KBC Void is nearly 10 times larger than anything like that. It's the biggest known structure of its kind ever discovered. And we are sitting inside it, right near the center. Now here's where things get really interesting, and a little controversial. For decades, one of the most important numbers in all of cosmology has been the Hubble constant. This is the rate at which the universe is expanding. Knowing this number is critical. It tells us the age of the universe, its size, its future. Scientists have two main ways to measure it. And here's the problem. They get to completely different answers. When astronomers look at the early universe using the leftover light from the Big Bang, called the cosmic microwave background, they get an expansion rate of about 67 kilometers per second per megaparsec. Don't worry about the units. The number is what matters. But when astronomers measure the expansion rate using nearby galaxies and stars, objects we can observe directly, they get a noticeably faster number. Around 73 kilometers per second per megaparsec. That's a roughly 9% difference. And in physics, a 9% discrepancy in your most fundamental constant is not a rounding error. It's a crisis. This problem has a name, the Hubble Tension, and nobody has fully solved it yet. But the KBC Void offers a fascinating possible explanation. Here's the idea. If we are living inside a large, underdense region of space, then the denser regions of the universe around us are pulling on matter, including us, slightly outward. Things near the edges of the void are being tugged by the gravity of all those galaxies clumped up outside the void. This means that nearby galaxies appear to be moving away from us faster than they really are. Not because the universe is actually expanding faster, but because our local neighborhood is being stretched by surrounding gravity. In other words, our cosmic location is giving us a skewed view. We're inside a hole, looking out, and we're misreading the universe's speedometer. Some researchers have run the math and found that the KBC Void could account for much, if not all, of the Hubble tension. It's not a solved problem, but it's one of the most promising leads astronomers have right now. But here's where the KBC Void creates a different kind of headache for scientists. Our best model of the universe is called Lambda Cold Dark Matter, or LCDM for short. It's the standard model of cosmology. It describes how matter formed, how galaxies cluster, and how the large-scale structure of the universe developed after the Big Bang. And according to LCDM, a void as large as the KBC Void simply should not exist. The model predicts that matter should be relatively evenly distributed on the largest scales. Voids exist, sure, but nothing this enormous. The probability of a structure this big forming under LCDM is extremely low. Some researchers have calculated it as astronomically unlikely. No pun intended. So what's going on? One possibility is that the void is a rare statistical fluke, an unlikely but not impossible outlier. Scientists have entertained this idea, though it sits uncomfortably with most physicists. Another possibility is that our standard model is incomplete, or even wrong. This is where an alternative theory enters the picture, MOND, or modified Newtonian dynamics, originally proposed to explain how galaxies rotate without needing as much dark matter. MOND changes the rules of gravity at very large scales. Under MOND, matter can collapse and cluster faster than standard physics predicts. That faster structure formation could naturally produce larger, emptier voids, like the KBC Void. MOND is still controversial. Most physicists aren't ready to throw out dark matter and rewrite gravity. But the KBC Void gives the idea a new ammunition. It's a data point that standard cosmology struggles to explain, and that's exactly where alternative theories thrive. Now let's take a step back from the physics and ask a question that has haunted humanity for generations. Where is everyone? The universe is 13.8 billion years old. It contains hundreds of billions of galaxies, each with hundreds of billions of stars. By sheer probability, intelligent life should have had billions of years to develop, spread, and make itself known. And yet, silence. No signals, no visitors, no evidence of anyone else out there. This is the Fermi Paradox. And the KBC Void might be one of the most underappreciated answers to it. Think about where we are. We're sitting inside a 2 billion light-year cosmic desert. The regions around us, the ones packed with galaxies and star systems and the raw material needed for complex civilizations, are far away. Not just a few light years, not even a few thousand. We're talking about distances so vast that no signal, and certainly no spacecraft, could cross them in any practical time frame. If intelligent civilizations tend to cluster in dense, resource-rich regions of the universe, and there's a reasonable argument that they would, then we might simply be living in the wrong neighborhood. Too isolated, too remote, too far from the galactic city centers where the action is happening. There's also another angle. The void we live in is underdense, which means fewer stars, fewer planets, fewer opportunities for life to take hold nearby. Even if life is common in the universe at large, our local corner of it may just be sparsely populated. We might be like a small town in the middle of the Nevada desert, wondering why we never get visitors while not realizing that the nearest major city is thousands of miles away. It doesn't mean we're alone in the universe, but it might mean we're alone in our neighborhood. And that, for all practical purposes, might feel like the same thing. Let's bring this all together. We live inside one of the largest known voids in the observable universe, a region called the KBC Void, stretching to billion light years across, 20% emptier than the cosmic average. We didn't choose this location. We just happened to form here, in this quiet, underdense corner of an otherwise bustling universe. And this location has shaped everything. It may be biasing our measurement of the universe's expansion rate, creating an illusion that the universe is expanding faster than it really is, and fueling one of the biggest unsolved problems in modern cosmology. It may be telling us that our best theory of how the universe works, the Lambda Cold Dark Matter model, is missing something important, maybe something big, and it may be offering us a quiet, humbling answer to why the cosmos seems so silent. We're not at the center of a thriving galactic metropolis. We're in the outskirts, in the void. But here's what I find remarkable. We figured this out, sitting on a pale blue dot, inside a barred spiral galaxy, in the middle of a cosmic hole. We still managed to map the structure of the universe around us. We noticed the emptiness. We asked why, and we started connecting the dots. That's not a small thing. That's one of the most extraordinary things a species has ever done. The universe is vast, ancient, and still full of mysteries. But every time we discover something like the KBC Void, we get a little bit closer to understanding what all of this actually is and where we fit inside it. If this blew your mind even a little bit, hit that like button. Seriously, it takes 1 second, and it helps more people stumble across videos like this one. And if you want to keep exploring the strangest, most mind-bending corners of the cosmos with me, subscribe. We go deep here, no dumbing it down. Just real science, explained clearly. Drop a comment below. Does the KBC Void change how you think about the Fermi Paradox? Do you think we're alone because of where we live? Or do you think there's something else going on? I read every comment, and I genuinely love hearing what you think. Thanks for watching. I'll see you in the next one. Stay curious.